Hi guys, welcome to my channel, my YouTube channel, Learn Physics with IBM, and I am taking you to part 8. I think this is part 8 of solved past paper questions. This is force, density, and pressure. Without wasting time, I would like to take you to the document so that we solve these questions. So do not hesitate to subscribe, like the video, share, download the content in the video description. It may be useful for your personal studies. So without wasting time, I think in part 6 we stopped on page 60. I mean in part 7 we stopped on page 60. So in part 8 we should start from page 61. So let's go. A uniform meter rule is pivoted at 34 centimeter mark as shown. The rule balances when a 64-gram mass is hung from the 4 centimeter mark. What is the mass of the meter rule? So it is a uniform meter rule. That means its mass is at the center. So let me look for the center. It is at 50. So the mass of the meter rule here, the mass of the meter rule is at 50. So I'll call the mass M. But I don't want to use an arrow because the mass is not a force. So the mass of the meter rule is here and it is M. So M times the perpendicular distance from 34 centimeters. That distance is 50 minus 34, which I think it is 26. So that is 26 centimeters. Should be equal to, I'm taking moments about the support, about this point here. So this should be equal to 64 grams times perpendicular distance. This is at 4 centimeters. So from 34 to 34, that is the difference there is 30. So this distance is 30. The distance is 30 centimeters. So I'll just check my calculator by dividing both sides. I mean dividing by 26. So 64 times 30 divided by 26. So this gives me 70. Is it 70? 64 times 30. Let me check this again. 64 times 30. This is M. 50 minus, maybe I subtracted wrongly. 50 minus 34. No, that is 16. Sorry. This is not 26, it is 16. Okay, so I have to say 64 times 30 divided by 16. That is 120. So the answer is going to be C. That is 120. A ladder is positioned on icy ground and is leaned against a rough wall. At the instant of release, it begins to slide. Which diagram correctly shows the direction of the forces P, W, R acting on the ladder as it slides? Of course, it is leaning against a rough wall. That means there must be friction here. And because it only slides downwards, friction must be upwards. So friction must be upwards. There should be friction upwards. Friction is upwards. And if the normal reaction is in that direction, then the resultant reaction, the resultant force here must be somewhere here. So the question is, which diagram correctly shows the direction of the forces P, W, and R acting on the ladder as it slides? So when it slides, this part will move to the left. That means friction is in the opposite direction. So this is friction. That is friction. So friction should be in the other direction. So if the normal reaction is there, there should be a force in this direction here. So which diagram correctly shows the directions of course the weight should be vertically downwards. Okay, so P, the total force at this point will not be horizontal. It is not only the normal reaction, yet the wall is rough. And oh, the ground is frictionless. So there is, I'm going to rub off friction here. There's no friction. So at the ground, we only have normal reaction. So it should be perpendicular to the ground. So we eliminate D and C because at the ground there is no friction. the only force acting should be perpendicular, that is at 90 degrees to the ground. So C and D are out, remain with A and B. On the ground, we have a force which is perpendicular, but on the wall, there is a friction. So P will not be known only. The resultant reaction here will be at an angle between the friction upwards and the normal reaction. So the correct answer is going to be B, because P is acting at that angle, which means there is a normal reaction force and there is friction upwards. So P is between those two forces. So the answer is going to be B. The resultant of this one and this one should be P. This one shows there's no friction, there's only normal reaction, which is not possible. The maximum pressure that granite rock can withstand is 2.0 times 10 power 8 newtons per meter squared. Above this pressure, the rock begins to flow like a liquid. The density of granite is 2.7 times 10 power 3 kilograms per meters cubed. What would be the height of a pure granite mountain whose base is just beginning to flow? Height. Of course, here it is just pressure. Pressure is density, H density times G. So we want H. Pressure is 2 times 10 power 8. H is what we want. Density is 2.7 times 10 power 3. And G is 9.81. So by just pressing the calculator, 2 exponent 8 divide by 9.81 times 2.7 exponent 3. So I'm getting 7550.87, or approximately 7.6 times 10 power 3. So H is 7.6 times 10 power 3 meters. So the answer is going to be B. An air bubble in a tank of water is rising with a constant velocity. It is constant velocity. Acceleration is 0. Resultant force is 0. The forces acting on the bubble are X, Y, and Z. As shown, what describes the three forces? Of course, Z, there should be a weight vertically downwards. So it means there should be upthrust, should be upwards, of course. Since it is raising, the drag force must be downwards. And of course, the weight must also be downwards. So Z and W, one of them should be weight and the other one should be the drag force. Okay. What describes the three forces? Z is the viscous drag on the bubble. Y is the weight of the bubble. X is the upthrust. So we are sure X must be the upthrust because it's acting upwards. So X is the upthrust on the bubble and X is greater. So this one greater is going to be wrong because if I add X should be equal to Y plus Z if the resultant force is to be 0, so that the acceleration is 0 since it is moving with a constant velocity. So greater should not work. Greater will not work. X is not greater than Y plus Z. It should be equal to. But then let's check. X is the upthrust on the bubble. Z is the weight of the bubble. Y is the viscous drag. Of course, the viscous drag for an air bubble which is very light, the weight is going to be smaller than the viscous drag. So the weight should be less than the viscous drag. So it means Z should be the drag because and Y will be the weight. So the answer is going to be A. It won't be C because you can't say Y is the viscous drag and Z is the weight for an air bubble which is extremely light. Because it's extremely light, its weight is going to be smaller than the viscous drag. So the answer is going to be A. Z is the viscous drag and Y is the weight. The answer is A. The diagram represents systems of coplanar forces acting at a point. The lengths of the force vectors represent the magnitude of the forces. Which system of forces is in equilibrium? Okay. So if The system of forces is to be in equilibrium. It means when when these are joined head to tail, they should form a closed triangle. So if you have a ruler, you may measure these lengths with a ruler. I'll just check this one. So the for on the for A, the vertical force is represented by a line which is approximately 1 point. I'm measuring with a ruler approximately 1.3. So I'll draw the vertical line here, which is approximately 1.3. I'm drawing a vertical line at the which is approximately 1.3 on the vector here. So I've transferred the vertical vector here, and I am going to add the vector which is horizontal is approximately 1 point around 1.8 centimeters. So let me check, about 1.8 centimeters. So when I measure about 1.8 centimeters, it is stopping there. So this is the one in the horizontal. So I think the answer is going to be A, because when the three vectors are joined head to tail, they are forming a closed vector triangle. So the answer, this is the one which is vertical, this is the one which is horizontal. So that is equilibrium. When three vectors are joined head to tail and they form a closed triangle, then we have equilibrium. They are representing forces acting on a body that is in equilibrium. When ice melts, it contracts. Which law is correct for ice turning into water? It contracts. That means the volume decreases. The volume decreases. Remember, density is equal to mass over volume. The volume decreases. So the volume decreases, but since it has just contracted, the mass has not changed. The mass has not changed, but the volume has decreased. If the volume decreases, it means the density increases. The density increases. So we ignore where the density has been decreased because the mass is not changing, but it contracts. The volume has decreased, so the density increases. Then the distance between molecules, of course, since it has contracted, the distance between molecules has decreased. So it means the answer is going to be B. The distance between molecules decreases because the density has increased, it has contracted anyway. So the answer is B. A W-shaped tube contains two amounts of mercury, each open to the atmosphere. Air at pressure P is trapped in between them. The diagram shows two vertical distances X and Y. Okay, so it's a W-shaped tube. So here there's atmospheric pressure, and here there's also atmospheric pressure. Okay. Atmospheric pressure is equal to the pressure that would be exerted by a column of mercury of height 760 millimeters. The pressure P is expressed in this way initially. So the pressure P is expressed in this way initially. Which values of X, Y, and P are possible? Which values of X, Y, and P are possible? So here, on the other side, on the left-hand side, we notice that the height of the liquid, this side, is above. That means the pressure P is going to be greater than the pressure on the left-hand side. So P is going to be equal to atmospheric pressure plus the pressure due to the height X, which is going to be H, density times the height X. P is greater than atmospheric pressure. So by a pressure given by this is going to be G times density times the height X. Then on the right hand side, the liquid, you notice that this height here is going to be 50. This height here is going to be 50 minus y. It is 50 minus y. And y is going to be, okay, that side is 50 minus y. So the pressure due to this height here is going to be G times density of Mercury times the difference in height, which is going to be 50 minus y. But I want you to notice that the pressure, because y is the height, because the height y is greater than the height x, so y is greater than x. Obviously, it means the pressure due to mercury is going to be above the atmospheric pressure. The pressure, the value of P is going to be above the pressure due to mercury by a certain value, which on this side, which is going to be approximately 20, because if on the left hand side, okay, so y is going to be greater than x. If you want to see this, if on the left hand side pressure P is equal to atmospheric pressure, maybe I can erase this to make it very clear. On the left hand side, P is atmospheric pressure due to the atmosphere, plus pressure due to this depth here, which is going to be density times G times X. And on the right hand side, pressure, the same pressure P is going to be atmospheric, because it is again higher, that it is raising the liquid, the gas this side has pushed the liquid the other side. So this is still pressure due to the atmosphere, plus pressure due to this depth, this height here, which is going to be density times G time into 50 minus y. So these two equations should be equal. When I equate this to this, P disappears, pressure due to the atmosphere disappears. I remain with rho Gx equaling to rho G into 50 minus y. So it means X is equal to 50 minus y. To get X, I'll get 50 minus y. But we notice from the diagram that y should be greater than x. So if y should be greater than x, this one is showing that they are the same and they are not adding to 50. These ones are not adding to 50. We have to choose between B and C. Remember, y is greater than x, so it means the answer is going to be B. As simple as that. In which example is it not possible for the underlying body to be in equilibrium? Aeroplane climbs. Aeroplane climbs at a steady rate. That means constant velocity, acceleration is 0, resultant force is 0. So it means this is equilibrium. An aeroplane tows a glider at a constant altitude. It is moving at a constant altitude. It tows a glider at a constant altitude. It means they said it is not possible for the underlying body to be in equilibrium. So it tows a glider at a constant altitude. It means the resultant force on it is 0 in the vertical. And it tows a glider. So that means this is also in equilibrium. A speedboat changes direction. So when I see change direction, I know that V changes, acceleration is not 0. So here acceleration is not 0 because of change in direction. So this one cannot be equilibrium. Two tugboats tow a ship into harbor. So if they are towing the two tugboats tow a ship into harbor, they can be towing the ship into harbor at a constant speed. So that one, there is a possibility of equilibrium. But when there is change in direction, the velocity changes, so the acceleration will not be zero. So the answer is C. Two blocks X and Y are falling through a vacuum in a uniform gravitational field as shown. Block X has weight 2W, block Y has weight W. The blocks do not move apart. Which value best represents the force exerted by block X on block Y? Okay, so the two blocks are falling through a vacuum in a uniform gravitational field. Block X has weight twice W. Block Y has a weight W. The blocks do not move apart. They do not move apart. Okay. Which value best represents the force exerted by block X on block Y? The force exerted by block X on block Y. So first of all, they are falling through a vacuum and they are falling in a uniform gravitational field. So because block X is on top of is above block Y, and they are simply falling, the force exerted by block X on block Y is actually going to be zero. The force exerted by block X on block Y is actually going to be zero. So you may ask yourself, why is the force going to be zero? You may think about Newton's second law, that actually if these two are in contact, X will exert a force onto Y, but Y exerts an equal but opposite force, so the resultant force is going to be zero. Y exerts a force on X, and X exerts an equal and opposite force on Y, and so the resultant is going to be zero. So the question is, which value best represents the force exerted by block X on block Y? And I'm saying this force is zero because this one is acted upon by the gravitational force downwards, and this one is also acted upon by the gravitational force downwards. So X is not exerting any force on Y. So the answer is going to be zero. A gas is contained inside a sealed syringe as shown. The volume of gas at room temperature is 2 centimeters cubed. Atmospheric pressure is 101 kilopascals. What is the work done by the gas when it is heated and expands to a volume of 6 centimeters cubed? So we know that work done is equal to pressure times change in volume for an expanding gas. The pressure is 101 times 10 power 3. And the change in volume is, we have 6 centimeters and 2 centimeters, so that is 6 by 10 power minus 6 to change it to meters cubed, minus 2 times 10 power minus 6 to change it to meters cubed. So we have 6 exponent minus 6, then minus 2 exponent minus 6. So this gives us 4. This is 4 times 10 power minus 6, roughly 4 times 10 power minus 6, or it is, I hope I did this, 1, 0, no, I didn't multiply this, 101 exponent 3 times 6 exponent minus 6, then minus 6 minus 2 exponent minus 6. Okay, so this is 0.404. 0.0404, 0.404, that is the work done in joules, 0.404 in joules. The answers here we have, if I multiply this by 1,000, it becomes 404 millijoules, and I think the answer is going to be B. It will not be C, it will not be D, it will not be A. So the answer is C, 404 millijoules. A fixed amount of gas is reduced in volume at a constant temperature. What is the reason for the increase in pressure? What is the reason for the increase in pressure? Okay, so if the temperature is constant and the amount of gas is fixed but the volume is decreased, so the average distance traveled between collisions by the gas molecules is increased, but not that the volume is decreased, so this is not true. It means that the spacing has been reduced. The average intermolecular attraction force between the gas molecules is decreased. When the volume is decreased, it means the molecules come closer, so the force of attraction could increase, so this is out. The average speed of the gas molecules is increased. When the volume is reduced, the average speed of molecules, yes, it could increase. But remember, the temperature is constant, and temperature is the average kinetic energy of the molecules, which is determined by the average speed of the molecules. So this one is not correct because temperature is constant, so the speed of the molecules does not increase. So the answer is going to be D. The frequency of the collisions of the gas molecules with the walls of the container is increased. In other words, the number of times they collide with the gas molecules, the number of times the gas molecules collide with the walls of the container has been increased. Not the speed, but the frequency. They oftenly collide with, because there is now a smaller distance to be moved, they will collide with the walls of the container many times or more oftenly. So the answer is going to be D. And the more the collisions, the higher the pressure. A U-tube closed at one end contains mercury. Air at pressure 5 times 10 power 4 pascals is trapped at the closed end. The other end is open to the atmosphere and is fitted with a piston of mass 5 kilograms and cross-sectional area 5 exponent minus 4 meters squared. The density of mercury is 13,600 kilograms per meters cubed. Atmospheric pressure is 1.01 times 10 power 5 pascals. So this is the U-tube. One side is open to the atmosphere. So what is the height h of the mercury column? Okay, so the liquid this side has pushed the liquid the other side. That means the pressure on the left-hand side is greater than the pressure on the other side. So if this side we only have atmospheric pressure, here we have pressure due to the atmosphere. So it means the pressure due to atmosphere, the pressure due to the atmosphere on the left-hand side. If I add it to the pressure due to the piston, the pressure due to the atmosphere on the left-hand side, if I add it to the pressure due to the piston, what is the height h of the mercury? Let me go back here. Okay, if I add the pressure due to the atmosphere to the pressure due to the piston, the total should be greater than the pressure of the gas. So this is going to be equal to the pressure, because the pressure of the atmosphere and the pressure of the piston are actually above the pressure due to the gas. No, let me just do it like this. So to find the pressure of the gas, because on the left hand side is pushing the right hand side, so the pressure of the gas is going to be the pressure of the atmosphere plus the pressure of the piston, and I subtract the pressure due to the height, the pressure due to the mercury, because the piston and the atmosphere are pushing the liquid mercury on the other side. So it means the gas is at a pressure which is lower than the sum of these two. But by what amount? By an amount which is due to the pressure of this height h. So it means the pressure of the gas is going to be the atmospheric pressure, which is 1.01 times 10 power 5, plus the pressure of the piston, which is going to be, of course, the piston has a mass of 5 kilograms, so the weight is going to be 5 times 9.81. The pressure of the piston is going to be the force over the area, so this is going to be plus 5 times 9.81 divided by the area, which is 5 times 10 power minus 4. This is the total pressure on the left hand side minus the pressure due to the height h, which is going to be the height h, which is known, not known, times the density of mercury, which is given as 13,600, then times g, which is 9.81. The pressure due to this height is h, density times g. So I just simplify this using my calculator. So on the left hand side, I have the pressure of the gas is given as 5. So I have 5 times 10 power 4, power 4 should be equal to, I'm going to press a calculator for this, 1.0. Okay, let me start with the fraction. 5 times 9.81 divided by 5 exponent minus 4 plus 1.01 exponent 5. So I have 199, 100, 199, 100 minus 13,600 times 9.81. So I have minus 133,416H. So I want H. I'll first of all take this the other side. So I have open brackets 5 exponent 4 minus 199,100 divided by the previous answer. So I'm getting 1.1. Of course, the minus is going to, because this is a negative here, H is going to be 1.11. 1.11 meters. So what is the height h of the Maclay column? Multiplied by 100, it becomes 110 centimeters. So this is 100 and maybe 11 centimeters or 110 centimeters to two significant figures. So the answer is D. Which pair of forces acts only as a couple on the circular object? Of course, this one is automatically going to be, remember, a couple, there should be two parallel forces. They should be equal in magnitude. Their lines of action should never meet. This is not a couple because they are not equal in magnitude. These ones, their lines of action will meet when you prolong them. These ones are acting in the same direction. A couple, they should act in opposite directions, equal in magnitude. Their lines of action should never meet. So the answer is going to be A. Equal in magnitude, opposite in direction, and their lines of action will never meet. So the answer is A. The diagram shows the cross-section of an Olympic-sized swimming pool filled with water. It is not drawn to scale. The density of the water is 1,000 kilograms per meters cubed. What is the difference in pressure between X and Y? Okay, that is an easy question. Difference in pressure. So you need that, you know that pressure is going to be density H times G, where we need the difference in the value of H. So density is 1000, G is 9.81. Then difference in height, we have 2.35. This height here, 2.35, minus this one to get the difference in the height for X and Y. So minus 2. So I'll just press my calculator, 1000 times 9.81 times 2.35 minus 2, that is 0.35. So this gives us 34, 33.5, 34, 33.5 approximately. This is approximately 34 or 3.4 kilopascals. So the answer is going to be B. A force acts on a wire to produce extension E. The same force then acts on a second wire of the same material, but of half the diameter. It is the same force, remember. And 3 times half diameter, 3 times length of the first wire. Both wires obey Hooke's law. What is the extension of the second wire? Of course, this is a placed question, but we shall still answer it. This question is supposed to be deformation of solids. Okay, so we know that Young modulus is equal to stress, which is force over area, divided by strain, which is extension of original length. So when we get the reciprocal, it becomes original length over extension. So for the first wire, the Young modulus is going to be equal to, remember, cross-sectional area is pi d squared. Area is pi d squared divided by 4. Or pi r squared, but r is d over 2. So it is pi d squared over 4. The 4 goes up. So for the first wire, this will be 4f. Its length, let it be L, divided by pi d squared times its extension for the first wire. Then for the second wire, because it is from the same material, Young modulus is the same. So E is going to be equal to 4. The force is the same, F. But they say the length is 3 times. So here I will say times 3L divided by pi. The diameter is half. So we shall put here a half d squared. Then times the extension, which is not known. I will use x this time. So these two equations should be equal. These two equations should be equal. So equating the two equations, we have that 4fl over pi d squared E should be equal to 4fl times 3 divided by pi d squared over 4 times x. So 4fl has cancelled, pi d squared has cancelled. So I'm remaining with the 1 over E is equal to the 4 in the denominator here is going to go up. So it becomes 3 times 4 over x. The 4 in the denominator here goes up. So when we cross multiply, x is going to be equal to 12e. So x is equal to 12e, which means our answer is going to be D. So the answer is D. Which statement best describes a couple? So we have already said a couple there should be two parallel forces, opposite directions, equal in magnitude. A pair of forces equal in magnitude, opposite directions, which produce rotational motion but not translational motion. So there's no resultant force, but they can cause rotation. So the answer is A without wasting time. The rest must be wrong. A couple can cause rotation but not translation. Rotation, that is, there is no rotational equilibrium. Translation means the body moves from one point to another. If there is no rotation, no translational motion, it means the body cannot move from one point to another. So the answer is A. A cross-shaped structure freely pivoted at O has arms of length 5 meters, 4 meters, 3 meters, and 2 meters. It is acted on by forces 2 newtons, 3 newtons, 4 newtons, and an unknown force F. The structure is in rotational equilibrium. That means there is no resultant moment. Okay. So what is the magnitude of F? As a science student, I will just you can just resolve this vertically to easily find the perpendicular distance from the point O. So taking 2 newtons to the vertical to be 2 sine of 30, which is actually 1 newton. So we want to find F. Now I'm going to take moments about the pivot. Clockwise moments, we have F alone is the only force acting clockwise. So F times its perpendicular distance, which is 5, should be equal to, we have 2 sine of 30 times its perpendicular distance, which is 4, plus, this is anti-clockwise, this is anti-clockwise. This one has no moment because it acts through the pivot. The component of 2 newtons to the horizontal also has no moment because it acts through the pivot. So this will be plus 3 newtons times 2. So we just check this. So that will be 2 sine 30 is 1, that is becomes 4, plus 6, which is 10 divided by 5, which is 2. So F is equal to 2 newtons. So the answer here is going to be B. A U-tube has one arm of area of cross-section A and the other of cross-section of 4A. The tube contains water of density 1000 kilograms and oil of density 850 kilograms per meter cube. The column of air, the column of oil on top of the water in the left-hand arm is of length 30 centimeters. What is the difference in height x between the levels in the two arms of the tube? Okay, so we can find pressure due to height, P, pressure due to height at the point. I'm going to find the pressure due to the height at the oil-water boundary, and the pressure due to the oil should be at this point here. Pressure due to the oil should be equal to the pressure due to the water at this boundary here. The pressure due to the oil should be equal to the pressure due to the water at the boundary. That is obvious. The pressure here should be the same because at the boundary, pressure acts equally in all directions. Then pressure in the left arm therefore should be equal to the pressure in the right arm. Let's find the pressure in the left arm. So using the expression that pressure is equal to density times G, pressure equals density times G times H. In the left arm, pressure due to the oil is going to be 30, or density, which is 850 times G times the height I will not convert, which will be 30 centimeters, should be equal to the pressure in the right arm, which is going to be, of course, this depth here, this for equilibrium, of course, pressure is equal, this is 30 minus x. So this is going to be the density, that side is equal to 1000 for water, times G, times that height, which is 30 minus x. So G has cancelled out. So that means 30 minus x is going to be equal to 30 times 850 divided by 1000. So what is x? So x is going to be equal to 30 times 850 divided by 1000. That is 25. No, 30 minus x is 25.5. So if I solve for x, x is going to be equal to 30 minus 25.5, which I think is going to be 4 Is it 4.5? 30 minus the answer. That is 4.5 centimeters since I didn't convert. So pressure due to the height at the point at the oil water boundary is what I was considering, but pressure due to the pressure of the oil is going to be equal to pressure of the water at that boundary. So it means the pressure in the left arm should be equal to the pressure in the right arm. And if that is true, I could just equate the two. And then I simplify, I get x as 4.5 centimeters. So the answer is going to be A. The diagram shows two ways of hanging the same picture. Okay. In both cases, a string is attached to the same points on the picture and looped symmetrically. It is symmetrical. So the angle, if we loop it symmetrically, the angles here are going to be the same. This is theta 1, this is also theta 1, they are equal. Looping it symmetrically, if this is theta 2, this is also theta 2. In diagram 1, the string loop is shorter than in diagram 2. Which information about the magnitude of the forces is correct? Okay. First of all, let's try to find a relationship between the tensions and and R. So if we resolve this downwards, we shall have for T1 to be T1 cos theta 1 and T1 cos theta 1. So we have that twice. T1 cos theta 1 should be equal to R1 on the left hand side. On the right hand side also, it means we shall have twice T2 cos theta 2 should also be equal to, I think this is R2. Okay, so I want you to notice very well that theta 1 is greater than theta 2. Theta 1 is greater than theta 2. If theta 1 is greater than theta 2, it means cos theta 1 should be less than cos of theta 2. The cos of theta 1 should be less than the cos of theta 2. And what does that imply? If I make T1 the subject on the left hand side, I have that T1 is equal to R1 divided by 2 cos theta 1. And on the right hand side, I have T2 being equal to R2 divided by 2 cos of theta 2. So if T1 is equal to R1 over 2 cos theta 1, and they told us these are attached on the same point and they are looped symmetrically, the forces over a nail in a wall, the forces shown are those that act on the nail. They said the string loop is shorter than in diagram 1, the string loop is shorter than in diagram 2. In diagram 1, the string loop is shorter than in diagram 2. So since theta 1 is greater than theta 2 and cos theta 1 is less than cos theta 2, chances are high that T1 is going to, because this one is going to be theta 1 is greater, so cos theta 1 is smaller. So this is going to be smaller. The denominator is going to be smaller. That means T1 is most likely going to be greater than T2. If we compare using just the denominators using cos, T1 is going to be greater than T2. So we eliminate T1, we eliminate T1 less, we eliminate T1 equal, remain with the T1 greater than T2. That is going to be possible if R1 is equal to R2. That means if we make R1 and R2 the same, T1 will be greater than T2. If R1 is equal to R2, we just call it R. Remember, cos theta 1 is less than cos theta 2. If cos theta 1 is small and yet R is the same, it means T1 is going to be greater. So this makes it the correct answer. A man holds a 100-Newton load stationary in his hand. The combined weight of the foreman and the hand is 20 newtons. the combined weight of the forearm, not foreman. The forearm is held horizontal as shown here. Okay, this is beautiful. What is the vertical force F needed in the biceps? Okay, here we're just going to take moments about the elbow. So this is going to be a clockwise moment, and in the biceps, if I do a vertical line here, it is going to be exerting anti-clockwise moment. So we shall simply say that F times the perpendicular distance, which is this distance here, 4 centimeters, should be equal to 20 times perpendicular distance, which is 10, plus 100 newtons times perpendicular distance, which is 32. So this is times 32. I didn't change the units because centimeters both sides to cancel out. So we have 200 plus 200 plus 3200 divided by 4, 850. So F is 850 newtons. So it means our answer is going to be a C. The spindle is attached at one end to the center of a lever of length 1.2 meters and at its other end to the center of a disc of radius 0.2 meters. A string is wrapped around the disc, passes over a pulley and is attached to a 900 Newton weight. Okay, so the question is, what is the minimum force F applied to each end of the lever that could lift the weight? Okay, so there's tension, there must be a tension here because this is 900 newtons, so there's tension here which is going to be 900 newtons. So there's tension here which is 900 newtons. So we are going to take a moment. This is I'm going to find this is constituting a couple. So we need another. So this is constituting a couple, and they said a spindle is attached at one end to the center of the lever, and at its other end to the center of the disc. A string is wrapped around the disc, passes over a pulley, and is attached to a 900 Newton weight. So this tension here of 900 is causing an anti-clockwise moment, and yet the couple should be causing a clockwise moment. So these two should balance. So the couple is force times the perpendicular distance between the two forces, which is 1.2, should balance with the moment due to the tension of 900 newtons, which is going to be 900 newtons times the perpendicular, because this is now the center here. So 900 newtons times the perpendicular distance, which is 0.2. So this is going to be 900 times 0.2 divided by 1.2. So the force F, which will balance, which will lift that, is 150 newtons. 150 newtons. So the answer is B. So we need 150 newtons to lift that. That is the minimum force that could lift that weight if we consider equilibrium. Okay, so that is very simple. Remember that if this weight is 900 newtons, the tension here is 900 newtons, and the thread or the string is a distance which is given as 0.2 from this center here. So I took moments by considering this horizon, this line for the tension with the perpendicular distance of 0.2 as, and this is going to be causing an anti-clockwise moment. Yet the couple, the couple is causing clockwise moment, so they should be equal. The diagram shows four forces applied to a circular object. Which of the following describes the resultant force and the resultant torque of the object? So these two add up to give us 60 newtons to the right. There's no resultant in the vertical. So the resultant force is not zero. That means we ignore the C and D. The resultant force is 60 newtons to the right. Then the resultant moment, this one is clockwise, this is anti-clockwise, they cancel out. This one is clockwise, this is clockwise, they do not cancel out. The resultant moment is clockwise, so it is not zero. So the answer is going to be A. The resultant force is 60 newtons, not zero. The resultant torque is not zero because it is the torque, this is 45 newtons causes a clockwise moment. Another 45 newtons, another clockwise moment, so they sum up. Of course, 30 newtons and 30 newtons, their moments cancel out since they're in opposite directions. But for the 45 newtons, they did not cancel out, so the answer is A. Liquid Q has twice density of liquid R. At depth x in liquid R, the pressure due to the liquid is 4 kilopascals. At what depth in liquid Q is the pressure due to the liquid? 7 kilopascals. So that is very easy. Pressure is going to be equal to density times G times height. So at this depth, at depth x, pressure is 4,000. This is equal to the density, which is 0, times G. The depth is x. That is for at depth x in liquid R. Then liquid Q. The pressure is 7,000. The density is, since the density of liquid Q is twice, so it will be twice rho times G. And let the depth be h. So I want to find h. I'll just divide the two equations. 7 divided by 4 is equal to twice rho G over rho G, twice rho GH over rho GX. Rho has cancelled. So h is going to be equal to 7 divided by 8. This 2 goes down to multiply with the 4. So it's 7 divided by 8, then times x. So the answer is going to be B. What is the condition for an object to be in equilibrium? Resultant force is 0, resultant moment 0. So let's check. Resultant force and resultant torque on the object must both be 0. So the answer is C. A uniform beam is pivoted at P as shown. Weights of 10 newtons, 20 newtons are attached to its ends. The length of the beam is marked at 0.1 meter intervals. The weight of the beam is 100 newtons, at which point should a further 20 newton be attached to achieve equilibrium. A further 20 newton be attached to be in equilibrium. So it is uniform, its weight acts at the center, it is 100 newtons. So the beam is 0.6 plus 0.4, that is 1 meter. So that is 0.5 meters, 1, 2, 3, 4, 5. The weight is here. For the beam, the weight is there, and this is causing an anti-clockwise moment. This is also causing an anti-clockwise moment. For balance, they should be equal. So it means this is causing a clockwise moment. So the resultant should be clockwise, I think. I mean, the resultant is anti-clockwise. To balance it, we need a clockwise moment. So let's check. Clockwise moments equaling to 20 times 0.4, which is 8 Newton meters. Anti-clockwise moments will be 100 times, because this is at 0.5 and this is at 0.6, so this is times 0.1 plus 10 times 0.6. So the anti-clockwise moment is 10 plus 6, which is 16 newtons. That is 10 plus 16, 10 plus 6, which is 16 newtons. So the resultant is equal to 16 minus 8, which is 8 Newton meters, and the resultant is clockwise, so the other one should be anti-clockwise, but where should we put it? So the other one should be anti-clockwise. Therefore, it's simply, if it is the resultant is 8 newtons, we need an 8 Newton meters. We need another 8 Newton meters to counter this 8 Newton meters. So, and remember, 8 Newton meters, to produce a moment of 8 Newton meters, the force of 20 newtons should be placed at 0.3, 0.5 as seen before. So it should be placed again there, so that here we have a total of 40 newtons in total. So it means the answer here is going to be D. Because the resultant is 8 Newton meters anti-clockwise, we need 8 Newton meters clockwise, which means we should place it at D. Alternatively, you would call this distance x, and then you just say clockwise moments should be equal to anti-clockwise moments. That is 10 times 0.6 plus 100 times 0.1 should be equal to 20 times 0.4 plus 20 times x. Still you will get x as 0.4 meters. That means point D. The Mariana Trench in the Pacific Ocean has a depth of about 10 kilometers. Assuming that seawater is incompressible and has density of about 10-20 kilograms per meters cubed, what would be the approximate pressure at that depth? Approximate pressure at that depth. I think this is direct. Pressure is equal to H density times G. So this is H is 10,000. Density is 10, 20. G is 9.81. So we have 10,000, 10, 20, 9.81. So that is 3, 6, 7, 8. 10 power 8. So this is 10 power 8. 10 power 8 pascals. So the answer is going to be D. A glider is descending at constant speed. Acceleration is 0. At an angle of 15 degrees to the horizontal. The diagram shows the direction of lift L, the air resistance R, and the weight W acting on the glider. Which vector triangle could represent the forces acting on the glider? Since it's at constant speed, acceleration is 0, the resultant force is also 0. So for equilibrium, we must have a closed triangle. Closed triangle. So if I fix W, then I draw without changing the direction. I draw R without changing R's direction. I draw R. Then on R, I should bring this one downwards. So this is R, this is L. So I would have such a triangle, vertical. I have this one, R, and I have L in that direction. So let's see which vector triangle could best represent the forces acting on the glider. So, of course, the weight should be vertical downwards. All of them are acting vertical downwards. Then R should not change direction. This one, R has changed the direction. Here also R has changed direction. Automatically here R has, okay, maybe they have maintained this R, but the angle here is with the horizontal is very large, so this can't be R. Second, we don't have a vector pointing this side, so it means this is not going to be correct. So it means the answer is going to be D. This is the weight, this is R, and this is L. You notice that it carefully matches the forces which we have on the diagram. So the answer is going to be D. And this is forming a closed triangle. So that means there is no resultant force. If you try to check, this one is closed, but the R has been reversed. This one is closed, but R is pointing in an awkward direction. This one is also closed, but this vector here has been changed. So the answer is D. Lastly, in this part, that's in part 8, the ball is falling at terminal speed in still air. The forces acting on the ball are upthrust, viscous drag, and weight. It is falling at terminal speed. Acceleration is 0. Resultant force should be 0. It is falling. Drag force must be upwards because it is falling down. It is moving downwards. Upthrust is upwards. The weight is the one which is downwards. So the weight must be drag plus upthrust. So what is the order of increasing magnitude of these three forces? The order of increasing magnitude of these three forces. The ball is falling at terminal speed. It means the drag force is constant. The drag force will be constant. The weight will be constant. The drag force is constant. The weight is going to be constant. The forces acting on the ball are upthrust, viscous drag, and weight. So since it is terminal speed, the drag force does not increase. So we can't say it is the greatest. So what is the order of increasing magnitude of these three forces? Before it starts moving, of course we know it was only having the weight. But then if it is moving in still air at a constant at a constant speed, in still air which is not really moving, which is not really blowing, then the upthrust depends on the difference in pressure on the top and the bottom. In the still air, the upthrust is going to be very small. So it means the upthrust must be the smallest force in this case. So that means this is going to be A, because upthrust is cross-sectional area times difference in pressure, which is cross-sectional area times density times G times difference in height. The density of A is very small, so it means for this ball, the upthrust is going to be the smallest, so the answer is going to be A. Okay, so see you in part 9. That is the end of part 8.